Howdy doody. Let's take a gander at number 31. The volume in cubic inches of the decorative box shown can be expressed as the product of the length of its sides as v of x is equal to x cubed plus x squared minus 6x. What linear expressions with integer coefficients represent the length and the height of the box? So let's just clarify a few things here. Number one is x here is given to us already and is seems to be the width because it's not labeled up there. And the height here is unknown. And the length of this is unknown as well. In fact, all of them are unknown because we don't know what x is. So we're just trying to find the expression like x or x minus 2 or something like that. Remember what volume is, and let me just show you real quick. Here, volume is length times width times height. So if I have a box here with a 10 here and a 17 here and a 22 here, and I wanted to find the volume, I would just multiply these three terms together. 10 times 17 times 22. That's the length times width times height. And that'll give you the volume. Well, what we're doing here in pure algebra love, instead of considering numbers, we're considering expressions. So x times something gives me x cubed plus x squared minus 6x. So essentially all it's asking us about is let's factor this. Just like we would down here. If we had the final answer for this, we could just factor it to find the 3, or the 3 potential. So let's factor that. First thing, I need to get the x out of the way there. So if we did v of x is equal to, and I pull out the x using the distributive property, so now we get an x squared plus just x minus 6. So really all it's asking us here is how do I factor this? And we already know how to factor that. We can use Snowflake, or you could just simply factor it if you have it in your head. A times c is 6, x goes in the wings, and a b is 1. And so we find two numbers that multiply to a negative 6 and add to a positive 1. So bring down this x right here, and then we get an x plus 3 there, and we get an x minus 2 there. And there we actually go. This here could be the height. We don't know exactly. And this here could be the length. But based on the diagram, I should probably switch those around because of the just what it looks like. So the length looks longer, so I'll choose that one, and that looks like the longer, the shorter one there. So what linear expressions with integer coefficients represent the length of the box? And there we go. So my length is x plus 3, and my height is x minus 2. And that's it. So all we're really doing is factoring. Notice I didn't have to do any division up here with synthetic or long division. I just did factoring. I probably could have figured out how to do some dividing, but I just did factoring instead. There you go.